Good morning, everyone, or good afternoon or evening, depending on where you are. This is another one of the in our series of webinars, which seem to have proven popular, and we're excited today to bring Hadley Wickham to the webinar to talk about collaboration and time travel, specifically how to collaborate with Git and GitHub using RStudio. So let me just say in advance that all materials can be found at these locations. You can tweet questions or you can post questions here in the panels. We'll try to answer them as we go along if we can, or I'll also be curating questions along the way, and Hadley will have a few minutes at the end to answer some of them. We'll have the recording up within 48 hours, so please be patient with us if you are eager to get the materials and so on. We'll get that out just as soon as we can. We'll send an email to all attendees. So we like to use these opportunities to let you know that there are other opportunities to learn more from us in person or on webinars. If you're going to be at Strata in San Jose, we'll have a small booth there. We'd love for you to stop by, so come visit us. We're also doing an R Day at Strata, so if you're already in attendance, we hope to see you at that day. We'll talk more about the packages that we offer and the products that we offer. Our next webinar will be coming up on March 4th. It's an interesting one by a guest speaker, Paul Teeter, who will be talking about how data science is changing. We hope you'll attend that. And also, if you haven't heard, we are taking on the road a course, a one-day course on Shining our Markdown, which will be in 3 cities in 1 week at the beginning of March. If you're in any of these cities you'd like to attend in person, please go to our website and go to Eventbrite and register. We'd love to see you at those. So with that, I think I'm going to turn it over to Hadley Wickham.
Great, thanks, Roger. So today I'm going to talk about Git and GitHub. And what I wanted to sort of focus on really is why I think that's important, why you should learn a little bit about Git and GitHub and why you should use it, rather than focusing on the kind of mechanics of how to do it. Because learning Git and GitHub is absolutely going to be frustrating at first. There's a lot of new terminology to learn, there's a lot of new techniques to learn, and you're going to make mistakes and you're going to get frustrated. So rather than kind of helping you over that initial hurdle right now, what I'm going to do is show you the endpoint, why you should deal with this frustration and this hassle. And to me, there really are 2 big payoffs to learning Git. So the first is safety, that Git and GitHub allow you to fail more safely. And if you can fail more safely, you can fail more quickly, and you can get to a successful place much faster. And the second big payoff is community, that there are thousands, maybe even tens of thousands of people using GitHub with Git and GitHub with R already. And by tying into that community, you can get lots of interested people to help you with your code. Now, I have made some effort to talk about the mechanics too. You can find it on this chapter in the R packages book. This is far from perfect, but it should give you a good place to start. At least it highlights kind of the important issues, the mechanics of how you set up RStudio, and some of the commands. So I'll show you a few of these today, but the focus is going to be on on why you should bother doing this, not how you actually do it. Now, this again is the R packages book. It's freely available on the web, and there will be a physical copy coming up around March sometime. So the first big benefit of Git is that it gives you safety. And I think this is really important because, to me, like the thing that's absolutely key to success is failure. The only way you get to a good place is by going through many, many bad places. If you want a good graphic, you have to do many bad graphics first. And the faster you can kind of fail, the faster you can do something wrong, the better you can get to doing something right. And Git is a really important part of that, is because it allows you to feel safe, that if you make a mistake, it's not the end of the world. If you do something wrong, you can easily roll back to a previous good state and proceed from there. So Git in many ways is much like using protection when you're rock climbing. That you want to be able to push yourself and go further, but you also want to feel safe that if you fail, you're not going to fall very far. You're going to get caught and then you can proceed again. So the goal of Git is to be like protection in rock climbing, so you can anchor yourself to the rock face so you don't fall too far. Now you might be doing this already, so there's a pretty common way of doing this, and that's just by every time you make a change, you save a new copy of the file. So this is a comic from PhD Comics, illustrating, what perhaps a typical data science workflow might look like without Git. You can have many, many, many files. You're going to have multiple per day. Some of them are going to have comments about how frustrating you're finding the process. And in fact, it's such a common problem that there's even 2 comics on PhD Comics about this. So creating multiple versions of the same file is useful, but it has some kind of big drawbacks. And I think the way to see that is to think about your project as a series of changes. So over time, you're going to start off in one place, and over time, hopefully, you're going to get closer and closer to the final result. And when you think about what do you want to store when you record a change, I think there are really 5 important things. So first of all, you need some kind of unique identifier. So you can say this change represents, this is the name of this change. And so if you're just using multiple files, that's the file name. You also want to know exactly what's changed, what lines of text changed, what code changed. You want to know when it changed and who changed it. And possibly most importantly, if you're coming back to a project that you haven't worked on for a while, why did you change it? Now, if you're just using this file naming system, well, you get a unique identifier, that's just the name of the file. It's pretty hard to see what changed if you've got a couple of arbitrary files sitting on disk. It's not terribly easy to say exactly how they're different. You get some information about when it changed, but you have to record that manually in the name of the file. No information about who changed it, and only very limited information about why it changed. And then obviously this file naming scheme is going to get harder and harder to coordinate if you've got multiple files. So if you want to change the data as well as the code, as well as the report, and keep all of those things in sync, that's going to be really painful to do just by copying the file many, many times. So Git provides a much better solution to this because it provides kind of an explicit model to this process. So every change, or in Git terminology is called a commit, is given a unique identifier. So that's called a SHA, and it looks like this. So it's a sequence of hex, so A, B, C, D, E, F, and the numbers 0 to 9. The SHA is actually really, really long. So the SHA is actually pretty much guaranteed to be globally unique. So across everyone making commits in all of their projects all over the world, you get a unique identifier that represents your change. That's called a SHA. That's really long, so most of the time within a project, we're going to abbreviate it just to 5 or 6 letters. So that's the unique identifier that represents a commit, a named state of changes within your project. And then that SHA is kind of a key into a database that provides more information, like who made the change, when it was made, and then a brief description that you write that describes the change. Now, those SHAs aren't very descriptive, so you can also name a particularly important commit. So you can use this git tag command, for example, to say this one represents a submission. And then there are some names that are added automatically, so that the head always refers to the most recent change in the project. Now I'm going to show you these a few of these git command line commands. Most of the time you're not going to use those. Most of the time you'll either use the RStudio Git interface, which I'll show you shortly, or you might be doing things through GitHub. It's useful to know about these command names, however, because if you want to get help, it's really useful to be able to Google for the name of the Git command. That's going to get you to a Stack Overflow answer or another documentation page that'll explain what's happening in more detail. So the other thing that's neat about this is because every change has a unique identifier, we can easily ask Git to tell us what's changed, or in Git terminology, that's called a diff, short for differences. So we can say what exactly changed between this commit and that commit. Now again, you're not going to type this usually. You'll see this, as I'll show shortly, either in RStudio or on GitHub. The other thing that's really useful about this is because you have the sequence of changes, if you discover you've made a mistake, now you can very, very easily roll back to a previous good state. And so you roll back, you were here, you roll back to something that worked, and now you can make a new set of changes that are actually the correct thing. Now, the thing that's interesting to note here is this mistake doesn't just go away. And that's important because sometimes the mistake you make is undoing something that you thought was a mistake, but actually isn't a mistake. So sometimes you want to be able to undo and undo. And the thing that's great about Git is that with very few exceptions, every Git operation is undoable. So unless you do some risky things, Git is not going. Git keeps everything you've done. There's no way to lose information. So you have that great sense of safety that no matter what you do, you could always roll back to something, to a state that worked for you before. Now, when you start learning Git, it's certainly possible to get yourself into a place that's very, very difficult to undo. You might be a little bit confused about what you did in the first place. There are some great resources online for kind of stepping you through the options. And if you want to see more of those, links to from the Git and GitHub page in the R packages book. Now, there are some kind of riskier things. You can actually do like time travel with Git and GitHub. So you can actually kind of go back in time and say you identified, well, I never should have made this change in the first place. You can actually kind of go back in time and remove that and pretend it never happened in the first place. Now, that's an example of an operation that's pretty risky to do in Git because you're actually going back. You're effectively going back in time. This is the same kind of time travel conundrum. If you're going to travel back in time, you want to be very careful not to accidentally do something that kills your own grandfather, preventing you from being born. So Git, in many ways, is much like R. It prevents you from doing very, very, very few things. You can do pretty much anything you can imagine in Git or in R, but there are a lot of things that you should just never do unless you are really, really certain it's the right thing to do. So I'm going to show you a little demo of this. I recalled just before starting this presentation, there's some other examples you might want to see. We'll talk about this later. But actually, all of the webinars, all of the code and the slides for the webinars are stored in a GitHub repo. So this makes it really, really easy for us to share, to work on the same project amongst RStudio and not jump on each other's toes. And you can see the history of the project by going in GitHub to this commits view, and that's going to show the sequence of changes over time. So you can see on the right-hand side here, we have the Git SHA, the unique identifier. And that's just an abbreviation for this very, very long string. That's just again, this globally unique identifier. And when we look at that, we can see, well, who changed it? Well, this is for Garrett's webinar, when he changed it 28 days ago, and why he changed it when he added the data wrangling webinar. Now, unfortunately, in this case, Garrett used Keynote files and PDFs, and there's no easy way to compare those files. But if we look instead for something that's, say, edited Markdown, you can see Kevin Ushee on December 17th made this change where he modified a URL. So instead of pointing to the Dropbox link, he pointed to the RStudio link. So this is really useful, right? If you're working on a project with multiple people, this allows you to easily see what people have been doing on that project. And my take on it is really that you're always working on a project with at least one other collaborator, and that collaborator is future you. So I often come back to a project, I have no idea, I only dimly remember ever doing it in the first place, and it's really great to be able to look at these commits and look at the sequence of changes to see what I did so it can help remind me why I was doing it. The other thing I wanted to point out is this. You don't have to use Git just for code. It's also great for doing text. So this R packages book that describes how to write R packages is accompanied also by a GitHub page. So this GitHub page contains the source, so we can look for this intro page. So here is the source RMD file that then gets turned into this web page. So you can see up here, this page is a lot of people contributing to it. I'll come back to again this near the end. But one of the great things about Git, and particularly GitHub, is just how easy it is for people to contribute code or contribute fixes to your code or your text. It's one of the really, really powerful aspects of GitHub, is that it's very, very easy to collaborate with other people. Otherwise, again, we can go to the commits, and we can see exactly who has made changes, when they made them. We have this unique identifier, the SHA again, and then we can see, click on an individual commit and see the diff, which lets us see exactly what's changed between the two versions of my project. Another little demo I wanted to show you is this vowels package. So the vowels package author wrote to me a couple of weeks ago saying, so they use in their package this package called Roxygen that lets you write specially formatted comments that then get automatically turned into R code or R documentation, which then you can see using the RStudio viewer. So the author got in touch because there seemed to be a bug with the latest version of Roxygen. It was making documentation that no longer passed some automated tests. So the first thing I did when I got this package is I put it in, I downloaded the source code from CRAN, and then I put it into a Git repo, and because that makes it really, really easy to see exactly what's going on. Because when I document the package using Roxygen, that's going to read all of these R comments. It's going to create these RD files. You can see it's writing a whole lot of RD files, and it just tells me that it's modifying them, but it doesn't tell me what it's done. So this is where Git comes in handy, because now I can see exactly what's changed, and if I go into the diff view in RStudio, I can see exactly how each file has been changed. So you can see for a lot of these files, all that's changed is this comment up the front. So the red indicates that this line has been removed from the old code, and this line has been added. So typically when you've got a red line and a green line combined together, that indicates that there's been a modification. So if we look at these files, we can see mostly that they're just to do with changing this initial comment. You keep scrolling through. Oh, here's a change that looks a little bit more significant. Well, that's not too interesting. All that's happened is this, the argument log in SP, which used to be down here, has now been moved up a little bit. Keep on going through. And then we find a significant change here that now this file contains some usage for some functions which now need to be documented. So the details aren't too important here. What I want you to take away is just how useful Git is for seeing what's changed. So no matter how you're changing that, whether you're changing that by hand, or you're working with collaborators who are changing it, or maybe you're worked with a collaborator which is past you and he's did something you have no idea why, or you're running some code that makes many changes. So it can be, similarly, it can be useful if you're writing reports with R Markdown. It can be useful to commit not just the R Markdown file, but also the Markdown file, because that's going to show you exactly what was generated every single time. So you can see if the data changed, how the results changed, how your models changed, how your output tables changed, and so on. So there are some other benefits to using Git with this approach. One of them is called Git Bisect, and Winston's kind of wrapped this up into a helpful package for R called Bisect R. But the idea is really simple. So often you make a mistake in your code and you don't realize it straight away. So you know way back here in the beginning of time your code worked. You had a good commit, but now at this point in time you have a bad commit, and you don't know when you made the change that broke it. So what you could do is you could check out this version and say, does it work? Then you check out this version and say, does it work? And then this version, this, and so on and so on and so on. But Git provides a way called Git Bisect that makes it this a little faster. And it uses this basic idea of binary recursion. So it's going to pick a commit in between the bad commit and the good commit, and it's going to test it. And so now if we discover that this is also good, then we know all of the commits between here and here must be good. So we've eliminated all of those tests. And now we pick another commit in between the last known good and the bad commit. We pick this one, and then if we know that's bad, then we know that's also bad, and now we've only got one left to test. So this is really, really useful because it rapidly, and here I've just shown 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 commits, but you can imagine maybe if you had 100 commits, then this is going to narrow down very, very quickly on the mistake that actually made a problem. So this has been pretty. We use this quite a lot for ggplot2 because if we accidentally made a change that made a small visual difference to a plot, we might not notice that right away. We might do lots and lots of other changes, and then we could use git bisect to very quickly narrow in on that commit that actually caused the problem. So that is the first big benefit of using Git, is that it gives you the sense of safety, that every change you've made is irrevocably stored in the history of your project, and you can always go back to it. You can always roll back in time to undo mistakes. You can help understand a new project by looking at the history of the changes. You can quickly narrow down using git bisect on a potential problem. It just gives you all of these great features for managing not just where your project is now, but where your project has come from. I think the other really big advantage to using Git and GitHub is the community that it allows you to buy into. And just this morning, there's some people tweeting about this. There's this website called GitHut, which shows what the most, it shows how GitHub is being used for different languages. So currently there are about 2.2 million repositories on GitHub, and of those, there are about 34,000 active R repos. If we scroll down a little bit, you can see there's been quite a lot of growth. So, only 2 years ago there were 1,000, and now there are 30,000. Now, most of this has been driven by the Simply Statistics Coursera course on reproducible research. So as one of the homeworks for that project, you have to fork or make a copy of a GitHub repo and make some changes to it. So if we look at the most kind of forked GitHub repos, you can see there's one repo by Jeff Leake that has 80,000 forks. So 80,000 people have made a copy of that repo, and another one by Roger Peng, a second programming assignment, which has been forked by 42,000 people. So there are a lot of people using Git and GitHub with R currently, and there are even more coming down the line through these classes like the Hopkins Data Science Coursera courses. There's a lot of great resources, a lot of people invested in using GitHub, and who will, as I'll show you a little later, might help you out. So everything I've shown you so far with Git, the advantages of using Git, is just all about using Git on your own computer. And GitHub is basically about publishing what you've done locally to the web so that anyone can use it. Now I'm going to be talking mostly about public repositories that anyone in the world can see. GitHub also has options for a private repository, so you can share it just within your organization or just within your research group. But I think there are really some big advantages to doing everything in public. Pretty much everything I work on is available immediately to the public, and I think that, to me, now should be your default. Unless you have a strong, compelling reason not to make your work available to the public, you should do by default. So when you use GitHub with a project, the first thing you get is kind of a reasonably decent home for your project in the web. You don't need to worry about creating another website for it. You can just use your GitHub page, and that's mostly because if you have a readme.md file in the top level of your project, GitHub is going to render that to HTML in a nicely formatted way so other people can see why they should use your package or why they should be interested in your project. Now, particularly, this is useful if you're writing R packages. R packages are really the best way to distribute code accompanied by documentation of data, because if you put an R package on GitHub, it is very, very easy for other people to use it. So, for example, with the DevTools package provides this function called install GitHub, which makes it pretty much as easy to install a package from GitHub as it does to install it from CRAN. So if you're ever interested in any of the development versions of my packages, the things I'm working on currently, you can always get them with install GitHub. It's possible that the version might be a little bit buggier, but it's going to have new features that are not available on CRAN. So again, the ability, when you start working with multiple people, the ability to look at the commits is really, really useful. So if we go back to the R packages repo, this really kind of emphasizes how much of a community process writing this book is. That there are many people who are contributing to this repo, and I'll show you how shortly, that are fixing bugs and finding typos, and that, I think, this is one of the reasons why I think working in public is so important, because other people can contribute to your work and they can help you make it better. And there's nothing better than the feeling of knowing that someone not only cares enough about your project to use it, but to contribute back changes to you. That's really, really great feeling. So you can see what's happening with these commit views. You can dive into an individual commit to see a diff, to see exactly what's different. I used to find this really, really useful when I was working on projects with students, because I could go in and review exactly what they were doing. And you can file comments on these things, so you can have a discussion in the issues to try and clarify why a change was made, or if you see a potential mistake. Now, every project on GitHub, every repo on GitHub is also accompanied by a issue tracking page. This is really, really great when your project gets bigger, because it allows you to track all of the outstanding issues. Now, I also find this really useful when I'm working on a project and I discover a bug in another project. You don't want to kind of kill your forward momentum by switching from project A to fix the bug in project B. With issues, you can just very, very quickly go to the repo page, go to the issues page, file that issue, and then when you come back to the problem in the future, you can recall exactly what problem you had. So this is used very extensively, for example, if we look at dplyr, which I haven't been working on for a while, you can see there's 125 open issues, 716 that we've closed. You can see an issue has an author, it has some description. If I find one that has a little more conversation, you can see that it's easy to have a conversation here that's better than email, because it's publicly available to everyone who's interested in that project. So these issues are also great for discussions, as I just showed you. You can also do those discussions in the commits. Let me see if I can, might be able to find an example of that quickly. Maybe not. Oh, I know this. I remember where one is. So for example, here is a commit that had 3 comments on it. And you can see there's a little discussion down the bottom. Someone just gave me a thumbs up, and someone asked, why did I change the name of the package? And then I can tell them, well, if you go to this issue, you can see why. And so GitHub, as you can kind of see here that I've linked to issues, GitHub supports something called GitHub Flavored Markdown, which makes it very, very easy to link between your issues and other repos and so on, which is not unfortunately documented here, and I always forget where it is documented. Yeah, so for example, you can very easily reference a specific SHA or a repo or an issue. So it's really, really useful when kind of helping to link between the problems and the commits that fixed them and so on. So I think one of the best features of GitHub is this the idea of a pull request. So a pull request is like an issue, but it comes with attached code. So a pull request allows someone to say, hey, Hadley, I found this problem with this repo, or I've come up with this new feature, and to send me the code that implements it. And then in this, and I'll just go back to a pull request I've dealt with in the past. Let's pick this one because it has a whole lot of comments associated with it. So, and all of those comments are unfortunately further back in time. But you can see, you can have a discussion about it. You can comment with particular code. You can see exactly what they suggest changing. You can give comments on it. You can say, hey, maybe this would be a better way of doing it, or that's a great idea. And this makes it really, really easy to integrate the changes that other people suggest into your own code. That this is, I think, the biggest benefit of taking advantage of the GitHub community, is that it's not just now it's not just you working on your code and you're writing, it's other people who contribute as well. And you can review those online, as I showed before. Now, there's some other neat integrations that you can do with GitHub. So, for example, there's this tool called Travis CI. This is what's called a continuous integration service. So basically what this does is whenever you publish or push your changes to GitHub, this is going to run some arbitrary code. So I use Travis for all of my packages. So when I push a set of changes to GitHub, Travis is automatically get those changes, and then it is going to run rcommand check for me and show me the results. So this ensures that as soon as I make an error with my package, I can find out straight away. This is a really, really powerful technique. It's not just great for code, but it's also great for writing. So I have similar things set up, say, for the rpackages repo. So as soon as a change is made to the rpackages repo, I run some code to regenerate all of the HTML, and then finally I deploy it to Amazon's S3, so to get a live website. So Travis is this really, I think, a really killer feature in combination with GitHub, because it allows you to run any code whenever your code changes. So you can use that to check that you haven't made any mistakes, and you can also use it to publish your code to a live website for people to use. And then the other thing that I'm taking advantage of that's particularly useful for package development is GitHub has the idea of a release. A release is just a named SHA. So you can see this is the commit. The SHA was 8244A93. I've given that a name. That is dplyr 0.41, and I have some nice. That's a pretty short one, but if we look at the bigger dplyr 0.4.0 release, you can see exactly what's changed, and you can see my summary of those changes. And then I typically go from this summary of changes and then make a summary blog post that's even further summarized. This lists every single bug and change in dplyr. So for any of my packages, if you're ever interested in seeing exactly what's changed between versions, you can always find the page on GitHub. You can always go to the releases and see how the package has changed over time and exactly what those changes were. Now to finish up, I just wanted to illustrate one of the cool things, other cool things about GitHub, and that is just how easy it is to contribute to someone else's code. So for example, Matt Jockers published this, I'm going to probably butcher the pronunciation, but Sureset package a few days ago, which allows you to do sentiment-based analysis and create plot arcs. So there's this RPubs post that describes how it works, but basically it allows you to take a book and kind of say over the course of that book, well, how are these different emotions being displayed? So for example, in this book, you can see maybe there's sort of a big peak around here that joy and sadness intermingled. But this package, it's on GitHub. It's actually really easy to install, but there's no installation instructions in this README. So what I'm going to do is open this README file. And on GitHub, I don't even have to download the code to myself, to my computer. I can just click Edit, and I'm going to say, I'm going to add a new section called Installation. This package is not currently available on CRAN, but you can easily install it with the DevTools package. So you need to get DevTools if you don't already have it, and then you can install it with mjocker/copy. So just preview those changes to make sure they're correct. That looks good. So now I'm going to propose this change to Matt. I'm going to say add and install instructions to README. So I'm going to propose this change. This is going to create a pull request for me, and You can see, as I showed you before, exactly what's changed. Matt's going to receive an email notification about this, and then he can choose to either discuss it with me further, or he can merge those changes to take my feedback into his repo. So this is a great way if, for example, you're looking at dplyr, and you're looking at the vignettes, maybe, and you discover some mistakes in the vignettes. You can just go to the source on GitHub. You can click this edit button. You can edit it on GitHub, and you can make the fix. I'm sure if I spend just a few minutes looking at this, I'll be able to find a typo. But it's very, very easy if you want to contribute changes back to do that. And in fact, if you look at the R packages website again, we go to, say, the introduction again, you'll notice every page of the book has an edit this page book. All that does is it takes you to GitHub, takes you to that edit page. You can then make changes. You can fix the typos and the mistakes that you found. Then you submit a pull request. I get notified about it, and then I can either say, hey, that's a great change, thanks a lot, or maybe you want to do this instead. So I think that's the really, really huge benefit to using GitHub, is that you can easily collaborate with other people. And in my experience, random strangers will even sometimes come by your repo and offer you improvements, even if they are pretty small. So kind of overall, I think hopefully I've shown you that I think Git and GitHub is really, really valuable. I think it really does give you sort of data science superpowers, but it absolutely is going to be frustrating at first. There's a lot of new vocab to learn. You're going to get yourself kind of into a place that you can't easily undo, although it's always possible. But that frustration is worth it because it pays off by increasing the pace of your development, because you don't have to worry about mistakes. And it also helps you to connect to an existing community of like-minded individuals who will help you make your code better. Thank you.
Hey, Hadley, that was great. Thanks. As data science and development kind of merge here with RStudio and R, this is obviously a really useful tool, along with other things out there like Subversion, for example. I think could also be used for doing this. You showed a little bit. I'm just looking at the themes. There are a couple of themes that are standing out in the questions. You showed a little bit about RStudio. It might be worth, if you could, I hate to put you on the spot, but go back and maybe share a little bit about how RStudio works with GitHub directly. A lot of questions about that. I think you went very quickly through that.
Okay, sure. Let me do that, and I'm just going to pick a repo that I've been a project that I've been working on a little bit lately. You may have seen this if you follow me on Twitter, but it's called Haven, and it makes it very, very easy to load SAS, SPSS, and Stata files into your R session. So let me see if I can, I think I know some changes I can make better. So it reads, so I'm opening up this file, which is, I'm just going to modify the documentation of this package. So this supports both the 7 DAT files and the accompanying V7 cat files that describe that SAS's equivalent of factor labels. Okay, so when I save that, so the first thing you'll notice when you work on a project that uses Git and RStudio, you get a new pane up here, the Git pane. And now when I make a change, when I save this file, you can see straight away that that's listed here. So this is great because one of the things that I do way more than very, very frustrating is I'll make a change to a file, I'll press Command S to save, but I accidentally don't press Command and I just press an S. And so then I end up with an accidentally with an extra character. And then when I reload my package, I get this error, and I'm like, well, don't remember how that happened. But I noticed over here in my Git pane, I can click on Git, I can see that change, and then I can actually undo it by saying revert. So that just seeing exactly what you've changed is really, really useful because it means that it makes it easier to not accidentally make changes. Now I'm just going to document this to generate um, the accompanying documentation file. Now again, so I've made these changes, and now I want to commit them. So what I'm going to say is I want these files to go in this commit. I'm going to describe it. I'm going to say improve documentation for read SAS, and then I'm going to commit it. So that makes a change that creates that SHA, that database entry, which has the changes. It has this description, improved documentation for read SAS. It has the person who authored it and the time, and here's that unique identifier. So now that just lives on my computer, and then I can push that to GitHub if I wanted. And now if I go to the corresponding site on GitHub, I can see I just made that change, improved documentation for read SAS. So you can see exactly what I did. So that cycle of when you use Git, you make changes to your files, you open up the diff or the commit pane, you select the changes you want to save or to commit, you write a message, and then you commit it. Hopefully that helps. And again, that was probably very, very fast again, but that's all described in much more detail in this Git and GitHub page if you'd like to learn more.
Okay, thanks, Hadley. Another theme that's worth commenting on are a lot of questions about private versus public repositories using Git in either scenario. And I think you pointed out that there is a private instance of it, but maybe you can just sort of give us a little bit more overview on that.
Yeah, so it's slightly tricky to show that because I can't really show. So firstly, I don't have many private repos, and obviously ones that are private I can't publicly share on this webinar. But basically what you can do when you create a repo on GitHub, you can choose to make it public or private. So we'll just create a test repo here. And so now if any of you try to go to this URL, this test repo, you can't see it. But I can choose to add people individually. So I could say, well, I want Winston to be able to work on this repo, and I want JJ to work on this repo. So now only Winston, JJ, and I can see this repo and can edit it. So this is kind of private repos is basically what GitHub charges money for. So if you're happy working in the public, it's all free. If you want to do private repos, I think you have to start paying money. Now this is still all obviously hosted on GitHub's website. If your company doesn't allow that, GitHub also has a enterprise version, which I don't know if I can find quickly, but I think if you GitHub Enterprise. So you can also run it completely inside your own company, so no code ever leaves the premises, and this is, as you can see, pretty popular thing to do these days.
Good. I think that answers that covered a lot of questions. There are many more, of course, than we're going to be able to get to. Do you want to take a second and maybe scroll through and pick out some?
Yeah. So there's some questions about how you can use Git, basically. So you can use it. There's sort of a lot of different. So Git is fairly complicated to use through the command line. And so what we've done with RStudio is to try and make some of the most common problems, common things to do, easier to do. GitHub also provides some clients that you can use that do much the same thing, although obviously they're not as integrated into RStudio. I use mostly Git through RStudio because it does most of what I need, and it drops down to the then I can drop down to the command line whenever I need to. Now there are lots of, someone mentioned SourceTree, for example. That's another Git client. I think basically you just need to do what makes sense for you. The GitHub client in RStudio is obviously not going to be as comprehensive as this program that all it does is work with Git. but on the other hand, it's going to be better integrated with R, and it's going to do the things that are most common, that R users want to do with GitHub. Again, if you'd like to learn more, I should mention that on this Git page, I do have, I think down the bottom, some resources about where to learn more. I think the two best places to learn more are first the GitHub help website, which is not just about GitHub, it's also about using Git. And then this book called Pro Git, which goes into exhaustive detail about how every aspect of Git works. So I think this is a little bit too much if you're just getting started with Git, because it kind of goes into a lot of details that you don't really need to understand straight away. But it's great for once you've been using Git for a little bit and you want to understand more about the details. GitHub help is particularly good for when you are getting started and if you've got stuck for some reason. It helps you get set up with Git, and it has all the instructions customized for whatever platform you're on. That's a really good place to, at least in the early stages, to get unstuck. And this Pro Git book is helpful when you want to learn more.
How about project versus Git repository? RStudio project versus Git repository.
So I kind of use those terms interchangeably, because for me, every RStudio there's a one-to-one mapping between RStudio project and Git repo. So basically, for every RStudio project I create, there's an accompanying repo somewhere. That's not the only way to use it. You can have multiple projects per repo, or you probably wouldn't have multiple repos per project. So, depending on your workflow, you might want to do other things. But I think, by and large, having one repo per project is the easiest kind of mental model.
And which version of RStudio server or RStudio were you using there?
I'm actually using the preview release.
On the desktop?
On the desktop, but it's very similar on the server as well.
Yeah.
I would encourage you to, I've been using the preview for a couple of weeks, and it's really great because there's some really neat features like a better data viewer and autocomplete and lots of other stuff. And for me in particular now, I'm writing a lot of C and C++ code. There's some great C code as well.
Thanks, Hadley. That was great. If you are not familiar with our professional product, which is how we pay for Hadley's good work and all the things, hopefully, that you're using from us in the way of Shiny and our Markdown and PackRat and Haven, and I can't even list all of the packages we put out there on CRAN. But we do that by selling RStudio Server Pro, which is an upgrade to the IDE that you saw Hadley using. It has features, not in addition to having a commercial license and offering support directly from us. It has performance and security and management features that are often very attractive to organizations that have many people using R in RStudio. And of course, we have RStudio Shiny Server Pro for those of you who are deploying Shiny or our Markdown applications, and you want authentication and security and performance and management associated with managing those applications. We'd love to talk to anybody interested in either of these products. And otherwise, want to thank Hadley and thank you for attending. We appreciate all of the interest, and as I said at the beginning, this will be sent to you. We'll also have it posted on our website within 48 hours. Please be patient with us as we get it out there. And that's it. Thanks a lot, guys.